The Internet of Things not only plays a major role in our private lives, but also in industrial context. Converting big data into smart data in order to monitor the status of a machine or even to avoid failures has many advantages. My name is Raphael Penning and I'm Product Manager at Turck. With me today is Nastya Eberts, Manager for e-learning at Turck, and we want to shed some light in data suppliers for condition monitoring and discover the advantages of smart data evaluation for condition monitoring and predictive maintenance.
Hi, Raphael. Hello. I thought we would start this discussion today with a nice cold drink and a toast to the Hannover Messe 2021. But unfortunately, the cooling system broke down and now we have rather hot juice instead of a nice cold Coke.
Well, a smart cooling system could have sent you an alarm before the fridge broke down. And we have enjoyed our drinks cold. Internet of Things enabled the tracking and monitoring of all kinds of industrial information. Not only just checking on your smartwatch if your robot just have finished cleaning your living room.
What is your experience? Do you already use all data providers in your application? Or are you planning projects with smart sensors soon and are interested in how to turn big data into smart data? The benefits of an effective monitoring of machine and system conditions and predictive maintenance are huge. Through the predictive maintenance, you can minimize downtime and maximize your machine's lifetime. But let's start from the beginning and take a closer look on where those kind of data is coming from. Okay, when talking about condition monitoring sensors or data suppliers for condition monitoring, we can differentiate between three kinds of data suppliers. First, of course, those sensors which are primarily made for condition monitoring purpose. Second, the sensors or data suppliers which are not especially made for condition monitoring but still provide valuable data that can be used for this purpose. And at least sensors that deliver simple data that can be interpreted in a smart way with, for example, the help of RG or a programming tool.
Okay, so let's take a look at sensors that provide data for condition monitoring. Let's say you are storing groceries in a storage room. It is important that the temperature and the humidity values are constantly kept within a certain corridor. With a temperature and humidity sensor that is installed inside the storage room, you can easily send the measured data to the controller level. This can be done by wire or even wirelessly.
From there, the data is sent via Ethernet or Modbus to the Turck Cloud Gateway and then optionally via Wi-Fi or UMTS to the Turck Cloud. Here you can monitor the temperature values at any time and even set up alarms if certain temperature or humidity value is exceeded or falls below. Some of you may work with motorized machines or engine. There is a simple way to detect irregularities or mechanical damage and to perform proactive maintenance. You can use, for example, a vibration sensor installed on the surface of the motor so that the vibration can be recorded directly on site. Here too, the sensor signals can be transmitted wirelessly to a gateway, which is directly connected with the Turck Cloud, for example.
If the vibration is too big or deviates from a reference measured under normal conditions, this is an indicator for mechanical wear or a defect. In this case, the PLC can trigger an alarm. The technician receives a text message or on his cell phone or an email, and he can maintain the engine.
Okay, those were two examples of data providers developed for condition monitoring and predictive maintenance. But condition monitoring does not start with installing a smart sensor. It starts with using and interpreting existing data in a smart way. And that is why we should talk about the data providers which are maybe already implemented in your machine.
You're right. If I think how many sensors inside Turck's portfolio not only measures distances or pressure anymore, those devices also can collect additional data, which our customers can use for condition monitoring or predictive maintenance. The UPROX3 IO-Link, for example, This little inductive sensor is able to collect not only the operation hours or the amount of switching cycles it has detected, but also the internal temperature as well.
When thinking about our cooling system fail from before, this sensor could have saved us from the cooling drink glitch. Maybe we should mount it inside our fridge to track the temperature.
Theoretically, yes. The sensors are not made for exact measurements. Therefore, this temperature information is not representing an accurate value, but it can be used as an indicator for temperature changes.
And you know what? With the other additional data of switching cycles, we can easily analyze how often the door was opened. And that would explain why some bottles are always missing.
Very nice idea. Yes. If you are using the UPROX3 inductive sensor for detecting the closed door, you also have the little doorman who's counting the entries. Another example of smart sensors for condition monitoring, I think about a customer from chemical industry. He's using our ultrasonic sensors for level measurement. So the device measured the height of the liquid and transmitted as a process value. However, this data can be analyzed in many ways. Let us assume that foam is forming on the liquid surface, which should not be the case in this specific application. Then the amount of reflected sound waves is reduced and the measurement becomes more difficult or even disrupts the production process.
Because the sensor provides the signal strength in addition to the pure distance value. This parameter can be used to detect the occurrence of foam formation, and in this way an alarm is generated based on the signal strength before the measurement becomes impossible due to further foam formation. You see, there are a lot of opportunities to check your application or machine and think how you can use already installed data providers wisely. At the beginning, we talked about 3 different kinds of data providers. Right now we talked about 2 of that kind. But let's talk about the third one, which is not especially made to provide data for condition monitoring, but still can be used with the help of programming for this kind of purpose.
Okay, for that, we should talk about standard sensors. Let me tell you an example from the warehouse. Packages are moved to a correct station via various conveyor belts and are directed onto another conveyor belt by shutters. So this shutter is always moving constantly. The end position of the shutter is measured by 2 sensors and shows whether it's opened or closed. But we get more information, important information, out of it.
Right. We take the 2 signals and measure the set time between the 2 end positions in normal operation. If the time between open and close increases, this can be an indication of a mechanical problem. If the deviation from the normal time is too big, an alarm can be generated.
As you can see, we can combine different signals or data to gather more information out of the actual application.
Another customer is already implementing predictive maintenance with our inductive sensor. Hundreds of containers are delivered to the port each day and sorted with the help of cranes. A spreader surrounds the container and the inductive sensor detects the end position of the rotating twist lock unit. Only locked can the container be lifted.
Frequent locking and unlocking or external forces can cause mechanical wear, and the position of the locking unit cannot be longer precisely determined, which leads to a direct machine stop. This wear or deformation can be figured out by a changing of the distance between the rotating target and the sensor. At the first small changes in distance, an alarm can be triggered to initiate preventive maintenance. This avoids unpredictable downtime.
And with RG, a lot of data can be newly interpreted. For example, it is quite simple to monitor the conveyor belt and generate an alarm in the event of a stop. Let's assume an analog I/O link sensor measures the distance to the products on the conveyor belt. This means that the distance is constantly changing, and when the conveyor belt is empty, the distance is particularly long because it measures up to the wall that is behind the conveyor belt. However, if the conveyor belt stops, the distance does not change anymore, but is constant, and those triggers an alarm. So normal state, distance changes; alarm state, distance remains constant. Very easy programmable with RG.
Right. Another interesting scenario for condition monitoring can be found in application with changeable tools, like, for example, two-part metal presses. With RFID tags, every tool can be identified. When both parts are mounted inside the machine, the system can double-check if the correct tools are currently installed into the machine by comparing the identification numbers from the tags. If those numbers doesn't match, wrong tools were mounted and the process must be stopped. This is also a very easy task for RG.
I think you already have some ideas about where condition monitoring data comes from. With our condition monitoring solutions for greenfield projects, we support our customers from the sensor to the cloud.
Turck is your global automation partner, and we offer a total solution from hardware to software. This not only saves you time and money, but also gives you benefits from perfectly coordinated components.
As important as condition monitoring is for the availability of machines, it should not restrict data transmission or lead to expensive upgrades. That is why we set the parallel query of process and status data via the same line.
As we have already discussed before, a separate sensor is usually not required for condition monitoring tasks. Instead, I/O link devices deliver both process data and acyclic device data in form of additional parameters or diagnostics. But even a standard sensor can provide important information with the help of an appropriated field bus station.
Turck's Ethernet cable I/O hardware supports 3 protocols: Profinet, Ethernet IP, and Modbus TCP. Because of this multilingualism, I/O systems or block modules can transmit pre-processed status data to an edge controller via dedicated protocol without affecting the process data communication with the controller.
Depending on the monitoring requirements, the flow of information leads from there either to the process control system or to the cloud, for example via OPC-UA or MQTT.
Many of you are probably wondering whether you can generate data in your existing system without causing downtime.
The retrofit solution from Turck can even be used in industrial plants that do not yet fully support sensor-based condition monitoring. You can easily monitor the condition of your machine in an independent system and send data wirelessly via a proprietary wireless network, if required. All the necessary devices are easy to install and set up.
First, you can use the data locally and monitor different parameters such as previously mentioned vibration, temperature, and humidity. Transmission modules of the proprietary DX80 wireless system send this kind of data to an associated gateway. You can also use a wired I/O link communication if wirelessly is not required.
Thanks to the connection to the TX700 HMI control unit, maintenance engineers can view all the condition data in one place. An Ethernet connection to the company network opens even more possibilities, including visualization via WebView, automated email notification, or data integration into your company's automation environment.
The other option is to use the TCG20 gateway instead of an HMI control unit to process the sensor readings from the field.
The gateway encrypts the data and sends it to the cloud via Wi-Fi or cellular network. Here, users can access to the data anywhere in the world.
The gateway can carry out decentralized analysis of the data, but data can also be analyzed in the cloud. Turck's industrial cloud allows you to create a personalized dashboard, view past trends, and configure automated emails or SMS alarms or messages. The TCG20 gateway also supports the Amazon Web Services and Microsoft Azure cloud platforms.
In summary, it can be said digital sensors and industrial technologies increase the amount of data which we can filter via decentralized automation and use for condition monitoring, or even furthermore for predictive maintenance.
If you would like to take the step into the IIoT world or have already done so and would like to use smart data for condition monitoring, then let's talk about it right after in the chat.
Thank you and have a nice day.
See you soon. Bye-bye.